to always start the recording first. That's what I want. Yes, that's what I wanted to begin with. So, I am going to temporarily unshare my screen and then reshare my screen. Because now I've got what I want. That. All right, today we embark on the world of fractions. Ooh, the F word, the math F word, fractions. Yes. And we're going to do, well, they're more interesting fractions because they're algebraic fractions. They have variables in them. They're not boring fractions like 2/3 or 5/2. They're more interesting. We're going to start off with something really, really important. That is, how do you know what the numbers are that will make the rational expression, which is just another word for fraction, the numbers that will make the fraction undefined? There's a general answer, and that is right here. If you have a fraction, then you have a top. Forget it's called the numerator, but top. You have a top and you have a bottom. There might be one number down there. There might be one variable down there. There might be a whole string of terms down there, a really long polynomial down on the bottom. It doesn't matter. Whatever the bottom is, the numbers that make the bottom equal 0. That is your enemy. That is not, X is not allowed to equal whatever that number is. And so, if X is not allowed to equal a number, that means that number is not in the domain. Because the domain is all the numbers X is allowed to equal. So here we go. We're going to look at different rational expressions. And we are going to find the numbers that will make the rational expressions undefined. And then we're going to write what the domain is, because these two questions go together. What numbers will make the rational expression or the rational function, that is the fraction, what numbers will make the fraction undefined, and what is the domain when I take that number out? So here we go. Really, really important. Here we have a top, numerator. Here we have a bottom, the denominator. I don't care what's on top for this question, for these questions. What is the domain? What is the number that will make the rational expression undefined? Those are basically the same question, and they have nothing to do with the top. I only care about the bottom. Okay, so here the bottom is 11a plus 29. I need to know what is the number a equals that will make this denominator right here undefined. That is, to make the denominator equal 0. So I take the denominator, I set it equal to 0, and I solve for the variable. That's 0. 29 minus 29 is 0. So I'm left with 11a over on the left and negative 29 over on the right. Then to solve for a, I divide by 11. Boom, boom. So a equals negative 29 over 11. My goodness, what is negative 29 over 11? It would be negative 2 and a little bit more. You can look that up in your calculator, but I'm going to estimate where it would be. If this is 0, and this is negative 1, and this is negative 2, then negative 29 over 11 would be a little bit more than negative 2, so it would be located about here. I'm going to say it's there.
And Miss Barbara, the answer for that would be negative 2.63.
Thank you. Thank you very much. Negative 29 over 11. I am going to pretend it's that circle, thank you, right there. Now, I mean, there's no way to make it exact. So I'm even going to take my little white pen over here and put it in there. So I have a hole there. Do you see it? It's kind of an ugly hole. And now what this says is that all of the numbers on the left of negative 29 over 11 are okay. I can use those because they don't make the denominator 0. And I can use all of the numbers on the right over, yeah, all of the numbers on the right are okay also because they will not make the denominator equal 0. But a cannot equal under any circumstances negative 29 over 11. So a here, undefined at the number negative 29 over 11. So we have just graphed the domain. Now, often you might see this instead of these here, yes, instead of those there, you might often see something like this. Okay, that's another way to graph it. But you have just graphed the domain. That is, the domain has an empty place, a very little empty place, but an empty place right in the middle, right there, where negative 29 over 11 is. Okay, so let's look at how we would write this in set builder notation. Notice that we're using the letter A. I have to close the cat door because there's something beeping out front. It's a truck, but why not be proactive and just shut the cat door for a little while so that the minimum amount of sound will come in from the outside? Had a very upsetting event happen this morning. Just as I was supposed to start my 7:30 a.m. class, My dog pooped on the bed. Yes. Now, just think about it. It's Monday morning, and that is how my Monday morning started. It's gotta get better, right? I just had to share, mostly because of the video. Ever so often, some things have such historical importance, they should get into the video. Yes. Okay, I just wanted to share. Now let's get back to work. Let's write this in set builder notation. So we're going to make a brace, and the letter we're using is A, not X. So I'm going to write A and then bar, which means such that, but you don't have to know that. And then, you see, it really, set builder is so much easier for this, because the only problem with my domain is that A is not allowed to equal one number. And that is all I have to write for set builder notation. Pretty easy. On the other hand, interval notation I think is more fun. Notice the graph. Interval notation is based on the graph. All of these numbers are okay, and all of these numbers are okay. So what I'm going to do is write the end points of the numbers over here, which are negative infinity on the left, and negative 29 over 11 on the right, but I'm very careful to use a parenthesis, which means A cannot equal that. Get really close, but not equal. And then over here, leave a space here. I have the right side of negative 29 over 11. Really close, but not equaling negative 29 over 11, all the way to positive infinity. So I have these two intervals that are going to be stuck together with a U. They're going to be united with a U, which is what the U stands for. This U stands for union, which means it's going to stick two intervals or two sets together. It's like glue, almost. So here we've stated the number that this rational expression, let me erase my squiggle there. Yeah. All right, the number that this rational expression, well, I should say, the number that will make this rational expression undefined, because it will make the denominator equal 0. Then we graphed the domain. That is, all the numbers over here are okay, all the numbers over here are okay, but not negative 29 over 11. Then we wrote this in set builder notation, which is squiggle, squiggle, all A, such that A cannot equal negative 29 over 11. That's what it says. And interval notation, which is grouping the left group of numbers together and grouping the right group of numbers together, and then putting them together with a U. Why me? Why me? Go away. Decline. Yes. I should have put that on. Well, I'm not going to do it right now. Turning it upside down won't do any good, but I keep trying. All right, now the next one. X squared minus 12x plus 27 is at the bottom, and do I care what's at the top? not when I'm being asked about what number or numbers will make the rational expression undefined. I don't care about the top at all. I could even erase it if I wanted to, so I'm going to squiggle through it. I don't care what's there. I am going to take x squared minus 12x plus 27 and set it equal to 0 because I need to find the x that will make that equal 0. And then take those numbers out. So let's see, 27 equals 3 times 9. Oh. Yes, okay. And 27, positive 27 equals negative 3 times negative 9. Now, why did I choose the negative? Because this B number is negative. I need two numbers that will add together and give me a negative number. Well, if I add negative 3 plus negative 9, I will get negative 12. So I will factor and factor. I can do this the easy way because there's a 1 in front of the x squared. Remember, you can factor in a more easy way then. All I have to do is look at how 27 factors into factors that will add up to the B number, and that's negative 3 and negative 9. So I'll break up the x squared, put an x here and an x here, take a negative 3 and put it here, take a negative 9 and put it here, although now those are not negative signs, they're minus signs. Now I set each of these factors equal to 0 and solve. I add 3 to both sides, so I get x equals positive 3. I add 9 to both sides, so I get x equals positive 9. And so, undefined at the numbers 3 and 9. Now, I have to find those numbers and take them out of the domain. And I want to do that with my white pen. So, all right. Don't make anything easy now. I need to make it more narrow. We'll take it down to 3. Okay. Now, I need to find 0 first, so why don't I say 0 is here? Then I'll have, ooh, nope. I don't want to do that. How about putting 0 here? Then it's safe. I can put 0 wherever I want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since I'm going to take out the numbers 3 and 9, having numbers around them still keeps up a sense of where this is occurring. Okay, so now I am going to take my white pen over here and eliminate the 3. Goodbye, 3. And eliminate the 9. Goodbye, 9. Now I have two holes in my x-axis. The x-axis is where the domain lives. We call it the x-axis, but I mean up here, if I were using this, I would just call the x-axis the a-axis. Anyway, I now have 3 groups of numbers that contain numbers that are okay. from negative infinity to the left side of 3, hop over 3, then going from the right side of 3 to the left side of 9, hop over 9, and continue from the right side of 9 all the way to positive infinity. These numbers are all okay. These numbers are all okay. And these numbers are all okay. We just have 3 and 9 that will cause major trouble. So, yeah, most of the time you're going to see this and whoop and this. Ah, you boogers. Okay. Didn't think it would be this much trouble. Okay. Now, that's enough if you're graphing the domain. But we're going to write it in set builder notation and in interval notation. And the cat wants to get out. Okay, see, this is my life. All right, all right, all right, there you go. At least I'm not bored. Okay, so here, and our letter is X this time, so all X such that X does not equal 3, or X does not equal, does not equal 9. Or sometimes you see X such that X does not equal 3, 9. Sometimes it is written like that. All right, and interval, remember, is based on your intervals that you graphed. So we're going to have 3 intervals, negative infinity, comma, 3. That's the left side of 3, but not 3 itself. The right side of 3 to the left side of 9. And the right side of 9 to infinity, positive infinity. And we put U and U in between. So those are the ways in which I would write the domain. Notice I don't care what's up top at all when it comes to that particular question. You need to remember that. When we get deeply into graphing rational functions. Okay, so notice what I did. I made myself not even think about, there we go again, not even think about the top, don't care about it. Instead, took the bottom, the denominator, over here because it was convenient, and solved, set it equal to 0 and solved, and found out that X equaled 3 and X equaled 9. And what that means is that if I'm looking for the values of X that will make x squared minus 12x plus 27 equals 0, then this is how I'm going to find out. 3 and 9 are the numbers that such that if you stick them in there for x, you will get a 0. Try it. It'll work. If we had time, I would do it, but I'm asking you to do it. Does it really? Yeah, it really does. Okay, now one more. Don't care about the 5. Instead, I'm going to take 2z minus z squared over here. It doesn't have to be on the right. It's just that I have some spare space over there. I could take it down here too if I wanted to, but I don't. Okay. 2z minus z squared equals 0. Now I look at this and I say, oh, I can factor that by GCF. So I pull out the GCF, the greatest common factor, and that will leave me 2 minus z. Now I have two factors. I have z and I have 2 minus z, and the way I solve is the way I solve this equation is I set each factor equal to 0. So I'll have z equals 0 and 2 minus z equals 0. So I'll add z to both sides because I can, because it's an equation. So I'll have 2 equals z. So now we know the two numbers that will make this rational expression undefined, which are 0 and 2. Those two numbers will make the denominator equal 0. So let's see, if I want this to be 0, then this will be 1, 2, 3, 4, and -1, -2, -3, just to give it a context. And I'm going to see that I have to actually remove the numbers 0 and 2. There. And then, boom, 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 boom. Booming helps. Not really. But if I stop making noise, then it looks like there's a gap in the soundtrack, because there is a gap in the soundtrack because I'm not making noise. Okay, now set builder notation. Squiggle, and there'll be a squiggle over here. And now we have z, so all z such that z doesn't equal 0 or z doesn't equal 2. Now, or has a different meaning in math than it does in everyday life. In everyday life, or means something like this or this, but not both. In math, or means this or both. So it's a much more broad meaning than in English. Now in interval notation, we're just basically going to draw our three intervals. Negative infinity, comma, 0, parenthesis, u, parenthesis, 0, comma, 2, parenthesis, u, parenthesis, 2 to infinity. And so we have talked about numbers that make rational expressions undefined. And then we've written the ways, really, if you count graphing as a way of writing, and it certainly is. Here you have a picture of the domain, the numbers you're allowed to use. Here you have set builder notation. Here you have interval notation. Discussion. I'm going to save this. Okay. I don't hear anybody. I bet I've put everybody to sleep. Oh well. These things happen, don't they?
I'm still here.
Yay!
Barbara.
Yay! Some people. Alexa and Myra. Okay, now we're going to simplify rational expressions. Oh my gosh, what do you mean? Well, the book calls it simplifying rational expressions with a factor of 1. I've never heard it carried on that long. In most math books, simplify or reduce, okay? Simplify or reduce are used for this, and forget the factor of 1. Like I said, my life continues to be exciting. Okay, I'll look for that later. I have another one in my room because I know myself. Hello, you gonna poop again? Yes, you wouldn't. We'll go for a walk when I'm done, okay? We'll go for a walk when I'm done. All right, here I am. Ah. Oh no. Y'all, I can't believe this. All right, I've got to look for my stylus. Where did it go? Here it is. All right. Dog. I can't believe it. All right, we are going to simplify these guys quickly and completely. You know how? We're going to factor and cancel. That's what simplifying is all about when it comes to fractions. So up here, we've got 2 times 5 times x times x times x times x times x. This is, by the way, 10x to the 5th divided by 2x squared. Now I could do this pretty easily using the rules of exponents, but hey, we are factoring right now, so let's stay consistent. I factored the top, now I'm factoring the bottom. Cancel, 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 and then put back together what's left. We have a 5. Well, first, everything is gone on the bottom. So that's a 1, not a 0. We have a 5 left, and we have an x and an x and an x left. So that's 5x to the third over 1, but 5x to the third over 1 is just 5x to the third. So the answer is 5x to the third. Now, the reason for this is, just think about people. Think about politicians. That's enough to give you indigestion. Think about politicians. They cover themselves, you know, it doesn't matter what party, it doesn't matter what person. Politicians like to make themselves seem wonderful, okay? So they kind of cover themselves in this air of wonderfulness. And it takes some work to tear through the BS and get down to what they're really saying. Any of them. You have to be careful when you're voting. Make sure that you've factored out the BS first. Okay, we're going to do it again, but this time the factoring is going to take a slightly different form. We're going to notice that I do care about the top now. When I'm simplifying, I care about what's in the numerator, and I care about what's in the denominator. And if I can, I try to cancel something in the numerator with something in the denominator. And that's kind of fun. All right, r squared minus 81 factors into the difference of two squares. Boom, 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 boom. R, and then the square root of 81 is 9. The principal square root of 81 is 9. So I put a 9 here, and I put a 9 here. Now watch this, and you've got to pay attention to this. Put your plus here and your minus here. That is factoring by the difference of two squares. Can I throw the phone out the window? No, that wouldn't be nice. Okay, now 81. Notice there's a 1 in front of the r squared, so this is a trinomial. I can factor it by the quicker grouping method. 81 equals 9 times 9. No way 9 and 9 are going to add up to negative 18, but since 81 is a positive number, it will also equal negative 9 times negative 9. And it just so happens that negative 9 plus negative 9 equals negative 18. So, boom, 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 R. I've got a minus 9, boom, boom, and a minus 9, boom, boom. That's what you do. That's why we had to talk about factoring first, because you are going to continue the factoring. All right, up top we have r plus 9 times r minus 9. On the bottom we have r minus 9 times r minus 9. This r minus 9, remember they're grouped together as one thing. This r minus 9 and this r minus 9 will cancel each other. So I'll mark through them. And what I have left is r plus 9 over r minus 9. So I have simplified the rational expression r squared minus 81 over r squared minus 18r plus 81. Now, if you like, you can think about it like this. What is the difference between a rational function and a rational expression? If you think about it like this, f of x equals r squared minus 81 over r squared minus 18r plus 81. Okay? That's a rational function. Rational means fraction in math, in the math language. Rational function. Just this part is the rational expression if you take this all by itself. Okay, so this is the rational. I'm going to need more room. This is the rational expression right here. Since these problems are given to us without the f of x or g of x or h of x or u of x or v of x or a of x, whatever, they're expressions. Nonetheless, you'd treat them the same way. Okay, here I have a quadratic trinomial. Here I have a quadratic trinomial, but whoever wrote this is treating us very nicely. There's a 1 in front of the z squares. So that means all we have to do is look at the constant on the end. Positive 10 will equal 2 times 5, or, let's face it, negative 2 times negative 5. And negative 7 equals negative 2 plus negative 5. So we've taken care of that. Now, over here, negative 6 will equal, well, we know 6 equals 3 times 2. So negative 6 is going to equal negative 2 times positive 3, or positive 2 times negative 3. Now, that's a positive 1 right here. So if I add negative 2 plus positive 3, I'll get positive 1. So that's how I'm going to factor this. This is negative 2 times positive 3, and 1 is negative 2 plus positive 3. So now I'll come over here and factor. Boom, 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 over boom, 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 boom. So I'll put a z here, and a z here, and a z here, and a z here. I can only do that, again, because there's a 1 in front of the z squared. Otherwise, it all gets more complicated. Okay, I decided that here on top, I would use the numbers negative 2 and negative 5. And I decided that on the bottom, I would use negative 2 and positive 3. And look what happens. Z minus 2, grouped together as one thing, will cancel z minus 2 grouped together as one thing. So cancel, cancel. Factor, factor, cancel, cancel. Your answer is this, right here. That's what you would put in the answer box. Z minus 5 over Z plus 3. Okay, that's how you simplify. And what this does is it comes before multiplying and dividing rational expressions, because part of what you do is factor and cancel, which is simplifying. So let us go about factoring and canceling. Here we're multiplying x to the 7th power over 7x plus 49 times 5x plus 35 over 5 times x to the 9th power. All right, here's what we do. We take the first fraction, x, 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 x. 1, 2, 3, 4, 5, 6, 7 over, there's a GCF here. 49 is 7 times 7. So both of these terms contain a 7. I'm going to factor 7x plus 49 by GCF. 7 times x plus 7. Okay, times. Oh, there's a GCF. 5 goes into 5, and 35 is 5 times 7. So each of these terms contain a 5. 5 times x plus 7 over 5. Here we go. X times 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 x. Let me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, after I factor, I can combine these two fractions. When you multiply fractions together, you multiply the tops times the top times the top, and the bottom times the bottom. And now I'm all set to do that. And I'm going to get a different color. Here we go. X times x, well, no, not x times x, but x cancels x, 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 and x cancels x. And I see an x plus 7 here and an x plus 7 here. They cancel each other. And I see a 5 up there and a 5 down there. They cancel each other. Now I have nothing left on top but a 1. There's always a 1. Over 7, and 2 x's are left. That's x squared. And we have really cleaned this problem up. But you don't want to put these two together immediately, or you might find yourself multiplying x to the 7th times 5x, and then x to the 7th times plus 35, and you don't want to do that. So factor everything first and then combine the tops and the bottoms, and you'll be a lot safer. Or you don't even have to do that. You could say, well, I know I could combine these into one fraction, but why bother? I can still cancel, 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 cancel. I could still do all the canceling. So, you can do whatever you like. But look at all the garbage, if you will, that was up here and how we got rid of all of it by simplifying. You always answer a fraction question, even if it's a number fraction question, in lowest terms. Well, this is the way algebraic fractions get multiplied and simplified. Let's do it again. I like this. This is fun. But it is an indication of why you have to learn all these factoring methods and learn how to recognize which method you're going to use. Like here, these two terms have a z, so I'm going to factor by GCF. Here, this is a quadratic trinomial. I'm going to factor by factoring. Here, this is a z squared minus 9 squared. 81 is 9 squared, so you have a difference of 2 squares. So you got to stay on it. So our first fraction factors as z times z minus 9. And our second fraction. Now this could be a little hard, but it's a negative number, so it's going to have one positive and one negative factor. And since I know that 90 equals 9 times 10, I know that negative 90 will either equal negative 9 times positive 10 or positive 9 times negative 10. Negative 10. And so it's a matter of saying, well, if I add these two together, how am I going to get a positive 1? There's a 1 in front of that z. It's invisible. So negative 9 plus 10 is positive 1. So that's what I'm going to use. So boom, 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 z minus 9 plus 10. And I have factored the first question, the first fraction. Now I'm going to multiply it by the second fraction, but I have to factor that also. So I'll have boom, 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 z plus 9 times z minus 9 over z squared, which is z times z. And now I'm ready to cancel, or you can go ahead and connect and then cancel. Whatever makes you happy. So I will start off. I usually go left to right. This z will cancel this z. Now look, z minus 9 up here will cancel z minus 9 down here. So boom, boom, you can cancel that way too. That means I'm still stuck with that z minus 9, and I can't get rid of it because I also have a z minus 9 here. What are you gonna do? And it ends up that that's all we can cancel. So here's what I do now. I have a z plus 9 times z minus 9 that I could not get rid of. Oh well. And I have a z plus 10 times a z. Well, z is shorter than z plus 10, so I'll put that in front. That's just the way we usually do it. I don't know that there's a rule that says you have to. And there's your answer. Z plus 9 times Z minus 9 over Z times Z plus 10. So you factor, factor, cancel, cancel. There's one more multiplication problem. And then we start dividing. Okay, so you take them one at a time. Y squared minus 3y minus 28. Well, let's deal with 28 because there's a 1 in front of that y squared. So I take negative 28. And I look at the different numbers. The most common breakdown of positive 28 is 4 times 7. It's not the only one, but it's the most common one, quite honestly. But that's not going to do me any good. Oh, yes, it is. Because negative 28 will equal negative 4 times positive 7, or positive 4 times negative 7. And which ones do I add together to get negative 3? Well, positive 4 plus negative 7. So now I know how to factor this. And I'm going to go to that extra step of negative 28 equals positive 4 times negative 7, and negative 3 equals positive 4 plus negative 7. Now, down here, you only have 2 terms. So it's a binomial. And there's y times y here, and y times y here. So both of these terms contain a y times y, which is y squared. So we can factor this by GCF and make it y squared times 3y minus 7. And the way you check yourself is to redistribute the y squared. Y squared times 3y would be 3y to the third, and y squared times minus 7 would be minus 7y squared. So yes, I did do that correctly. Now over here, both of these terms contain a y. But that's it. 9 is 3 times 3, and 49 is 7 times 7. So I'm only going to be able to remove a y over here. And down here, since 49 is 7 times 7, each of these terms contain a 7. So I'm going to pull out a 7. So now let me write these in factored form. I will have a y and a y, and a plus 4 and a minus 7 over y squared times 3y minus 7 times. The only common factor here is a y. Y times 9y squared minus 49. Over. Now, both of these terms contain a 7. 7 times y minus 7. Well, this term needs to be factored more. This is 3y squared minus 7 squared. That is the difference of two squares there. So I'm going to copy down the whole thing again. Y plus 4 times y minus 7. And if you're wondering why I don't go ahead and cancel that y minus 7 and y minus 7, I worry it would mess me up if I don't do it all at once. Could I do it? Yes, I could. Over y squared times 3y minus 7 times y times the factorization of 9y squared minus 49, which is parentheses 3y squared minus parentheses 7 squared. So this is going to factor as the difference of two squares, which means I'll have boom, 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 boom. You got to say boom. I take the 3y and write it here and write it here. I take the 7 and I write it here and write it here. Then I put the plus here and I put the minus here. Meanwhile, down here I have a 7 and a y minus 7. Whew! Okay, good grief. Hello, George. George has just entered the conversation. George the cat. Okay, now. All right, let's do it. Let's do some canceling. I have not got a y plus 4 down here to cancel that y plus 4. But I do have a y minus 7 down here to cancel that y minus 7. So, thank you, George. So I'm canceling and canceling the y minus 7. Now, I have a 3y minus 7 that can cancel a 3y minus 7 up there. And not only that, see that y, that poor lonely y right there? Y squared, I'm going to rewrite y squared as y times y. That way, it's easier for me to cancel this y and that y. Now I'm looking to see if there's anything else I can cancel. And then I think I'm going to actually use red ink. Ooh, how about this? This is pretty. And I'm going to circle everything I've got left. I've got a y plus 4 and a 3y plus 7 on top. On the bottom, I have a y and I have a 7. So the answer, all that I have left, is going to be y plus 4 times 3y plus 7 over 7y. And if you're wondering why I didn't cancel that 7 with that 7, 3y and 7 are combined. They're grouped into being one thing. You can't take them apart to cancel just a 7. This is a monomial, this is a binomial. They're two different things. Okay, so this is our answer right here. These are trapped. You can't cancel, like that y could not cancel with that y, or this y could not cancel with that y, because they're grouped. They're grouped together. Same for the 7. Okay, so this is our answer over here. Now, we have one more thing to do, and that's study division, but really division, as you will see, is just another form of multiplication. So let's do this. When I do this, I mean, you could develop your own method, but when I do it, I wait until the most important step before I start factoring. And the most important step is this. You write your first fraction, 36c squared minus 25, which incidentally is the difference of two squares, over c squared minus 16, which is the difference of two squares. Now watch what happens to that division sign. I turn it into a multiplication sign. And I flip, I take the reciprocal of the second fraction. C minus 4 over 6c minus 5. Now I have a multiplication problem. That's the only difference in a division problem and a multiplication problem. You turn the division problem into a multiplication problem and all your problems are solved. Well, almost. You still have to know how to factor. 36c squared is 6c squared minus 5 squared over c squared, I guess I could put that in parentheses, minus 4 squared. Oop, there. Okay. Times c minus 4 over 6c minus 5. Okay, now I'm going to come over here. And we're going to factor this first numerator. Boom, 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 boom. I take the 6c and write it here and here. I take the 5 and I write it here and here. And then in the first set of parentheses, I write a plus. In the second set of parentheses, I write a minus. And I'm done with that one. Over. Now this is a perfect square minus a perfect square as well. So again, I boom, 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 boom. I take the c and write it here and here. I take the 4 and write it here and here. I put a plus here. I put a minus here. And I am done with the first fraction. Now, the second fraction can't be factored. Make sure I've got my sign right. Okay. Now, these fraction bars act like parentheses and group things together. But just to make canceling easier, you can put the parentheses around the two terms here and the two terms here. You don't have to though, because fraction bars group together what's on top and what's on the bottom. Okay, C minus 4 will cancel C minus 4. See, I'm not necessarily going left to right. I'm also going by what's the most visible, and C minus 4 just sticks out. And then as I look at the rest, I see that 6C minus 5 and 6C minus 5 are the same thing, but one's on top, one's on the bottom, so they will cancel and cancel. So that what I have left, what I would put in the answer box, would be 6C plus 5 over C plus 4. And we're done dividing. Okay, multiplication and division are almost exactly alike, except in the first step of the division when you have to flip and multiply. Flip the second fraction, not the first one. Okay, so when you do the homework, you'll discover, much to your amazement, that there are very few of these problems. I think there are only 4 and we did 3 of them. Finding the number that makes the rational expression undefined. There are only a few of the multiplication problems for you to practice. You can, if you want more practice, you can also hit similar problem. And there are a very few of the division problems, since they're so much like the multiplication problems. You can see that the secret to doing this is being able to factor. And that's what we spent all last week doing, is learning factoring. So this is your opportunity to keep practicing. Okay.
Yes. Yes.
Discussion. Discussion, questions. Or you want to just go home and practice it. Practice that factoring, doggone it. Get that factoring done. Okay. Well then, George and I will bid you adieu and hope that you have a wonderful day. It is so chilly outside. I don't have any heat on right now, and it's 68 in my house. The animals are just delighted, but I'm going to wear a sweater all day. So you all have a wonderful day. Bye-bye unless you have questions.
I actually have a question.
Okay.
Yes, ma'am. I think there's something wrong with my canvas.
With your what?
My canvas?
Your canvas.
Yeah.
Okay, what?
I was trying to log in to do my work last night, but there is my Mac app. It doesn't like show up.
I emailed everybody. If you look through your email, you'll find out that it's now, the link is now on the home page.
homepage? Yes, ma'am.
Okay,
Thank you.
thank you.
You have a great day.
You too.
Bye.
So the homework is on the homepage, right, Miss Barbara?
The link is on the homepage. That's right.
Okay, link is on the homepage. Okay, gotcha. Alrighty. Well, I will see you tomorrow.
Okay, bye.
Bye.